G'day everyone. Day 7, Lightwave amplitude modulated transmitter and receiver pair. This isn't quite as advanced as I had hoped to get done, but unfortunately some unforeseen circumstances occurred. My wife unfortunately has become sick and has been taken to hospital, so I've been a bit busy with that. But rather than think too much about that, I came home this afternoon and whipped this up quickly and thought I'd shoot the video. Not entirely sure how much free time I'll have in the next few days. She's okay and will be fine, but she'll have to have surgery tomorrow. So we may not get a project a day for a little while, and I think some of the write-ups may have to wait for a few days. Apologies, but life happens. Okay, so really simple. We've got a current source here that's basically a single transistor current source set to around about 10 milliamps. Vary the base bias to move the current a little bit up and down. This modulates the light output of a red LED or a laser diode. Laser diodes are more problematic because they have a lasing threshold. You drop below a certain level, they stop lasing, and you go up too high and they blow up, whereas red LEDs are far more forgiving and cheaper, etc. I've got both though to show you the circuit operating with it. Red LEDs work fine, and with some optics you can get some pretty darn good range. This is a very primitive circuit. The feedback, there's no feedback to cancel any non-linearities, but the audio quality is surprisingly good for, what is it, 1, 2, 3, 4, 5, 6 components. Yeah, you can't really complain. This, of course, is all at baseband, so it has to compete with buzz and noise and you name it from all the light pollution, but it's not too bad for the first attempt. I think later on we might do an FM subcarrier system as well. What I wanted to do is build a test oscillator so I can tweak this front end for noise and high frequency performance. The receiver is pretty simple. It's a transimpedance amplifier. I've basically just thrown together these values. I haven't optimized it for noise or for any kind of frequency response. BPW34 is the pin diode being used. It's operated in reverse bias mode. It's probably could do with a bit better cleaning up the bias supply for it. I've only got 100 nanos here, the 4K7 to the positive rail. The fake rail splitter here with 2 resistors to just bias the op amp into somewhere near mid rail, and the output goes into the day 2 amplifier for reproducing the sound. Pretty simple system. Range is nothing to write home about without optics, but it certainly works across the room in the dark without optics. But what I did do is I actually brought home some bits and pieces here from the local store. I got some ping pong balls I'm going to use for diffusers for some test equipment. In particular, I want to do some get a bit of a feel for the exact properties of the photodiodes and the LEDs, so I need a way to diffuse the light a bit when I'm doing experiments on that. We got some El Cheapo magnifying glasses that will be used for optics, and I've got some black cardboard that I'm going to roll into a tube to house the optics, so it won't scatter too much light. Hopefully, pretty simple stuff. We should be able to get hundreds of meters without too much of an effort, and probably a kilometer if I pushed it hard. People send, with the Ronja project that sends 10 megabit data over 1.5 kilometers or so with technology that isn't particularly different in a lot of ways. So here's the actual prototype. The transmitter up here, as you can see, single transistor, really simple circuit. I'm running off a battery. Audio is being provided by a radio receiver, and this is the receiver here. You can see the photodiode, and the day 2 project here is the audio amplifier driving the speakers. I fiddled a little bit with the bias on this. The bias shown in the video wasn't particularly optimal for large amplitude. I'll update the documentation when I get around to writing it on what I did. It pulls more power now, and the devices are getting a little bit warm. I might fiddle with the quiescent current a little bit in the future, but it still works pretty well. Okay, so let's point the LED at the detector here. So yeah, it works pretty well, pretty low distortion. The threshold of the lead is a bit different to the laser diode, so if I pull the lead, I connected the laser diode in parallel. As you can see, it's lasing just. The acceptance angle is obviously much smaller for the laser diode because it's a much more coherent source, but theoretically the laser diode going with a lower divergence might be better, but it probably can't be pushed quite as hard as the LEDs can, and I've got some very high power LEDs in the junk box somewhere, and I might build a more powerful transmitter. The FM subcarrier system would obviously be preferable because you can simply switch the LED on and off, and you can drive it with as big a current pulse as it can stand for whatever duty cycle you're operating on. Yeah, I'll have a bit more of a play with that over the next few days, and it might feature in another video. I've got a couple more ideas, one of which is a practical problem for someone at work who's doing some stuff for Christmas himself. I think he has a solution for it in using a microcontroller, but I might do it using a bit of discrete electronics just for the fun of it. Yeah, and until the next video, don't quite know what we're going to do next. Might be some radio, might be some more optical stuff, and again, I don't really know when it's going to be, but we'll see if we can squeeze in some videos here and there. Alrighty, till then, bye.